Article 220.30 of the National Electrical Code provides an optional calculation method for dwelling unit loads. The question arises whether this section can be applied to calculate the load in an individual apartment unit, especially when each unit has a single feeder operating at 120/208 volts and includes common appliances such as an electric range, dryer, dishwasher, disposal, microwave, air conditioning, and electric heat, and the ampacity exceeds 100 amps. The answer is yes, it is permissible to use the optional calculation in Article 220.30 to calculate the load in an individual apartment unit. While Annex D provides examples that focus on whole buildings, the language in Article 220.30 does not explicitly restrict the optional calculation to entire buildings. The intent of Article 220.30 is to offer a simplified method for estimating the load for dwellings, and this intent applies equally to individual units and entire buildings. The factors considered in the optional calculation, such as the number of bedrooms and the presence of specific appliances, are equally applicable to individual units as they are to whole buildings. When applying the optional calculation for an individual unit, several additional considerations should be taken into account. Firstly, it is important to ensure that the feeder size is sufficient to handle the calculated load. Secondly, the optional calculation does not account for the potential simultaneous use of all appliances, so it is prudent to add a safety factor to the calculated load. Thirdly, the local electrical code authority may have additional requirements or restrictions regarding the use of the optional calculation for individual units, so it is always advisable to consult with the local authority before relying on the optional calculation. In summary, it is permissible to use the optional calculation in Article 220.30 to calculate the load in an individual apartment unit, provided that the feeder size and safety considerations are taken into account. This approach aligns with the intent of the Code to simplify load estimation for dwellings, whether they are individual units or entire buildings, while ensuring electrical safety and compliance. When performing load calculations for dwelling units, specifically when using the optional calculation method outlined in Article 220.30 of the National Electrical Code, several key steps and considerations must be addressed to ensure accurate and safe electrical system design. Firstly, gather comprehensive information about the dwelling unit. This includes the square footage of the unit, the number of bedrooms, and a detailed list of all appliances and the electrical equipment that will be installed or used within the unit. This list should include the rated voltage, amperage, and wattage of each appliance. Secondly, determine the general lighting and receptacle load. According to the standard calculation method, a general lighting load of 3 volt-amps per square foot is used for dwelling units. This value accounts for general illumination and the use of convenience receptacles throughout the unit. For the optional calculation, the general lighting and appliance load is typically factored into the overall calculation based on the total square footage in the presence of specific appliances. Thirdly, account for small appliance and laundry circuits. The National Electrical Code requires a minimum of 2 20-amp small appliance branch circuits for the kitchen and dining areas, and at least one 20-amp laundry circuit. Each of these circuits is typically calculated at 1500 volt-amps. Under the optional calculation, these loads are considered within the overall demand factors applied to the total connected load. Fourthly, calculate the load for fixed appliances. This includes appliances such as electric ranges, ovens, cooktops, dishwashers, disposals, water heaters, clothes dryers, and air conditioning units. The nameplate ratings of these appliances in volt-amps or watts should be used to determine their individual loads. For ranges, the National Electrical Code provides specific demand factors based on the rating of the range. For example, a range rated between 8.75 kilowatts and 12 kilowatts can be calculated at 8 kilowatts. For other appliances, the full nameplate rating is typically used unless specific demand factors are applicable. Fifthly, determine the heating and cooling loads. The larger of the heating or cooling load must be included in the calculation. For air conditioning and heat pump equipment, use the nameplate rating of the unit. For electric heating, use the total connected load of all heating elements. The National Electrical Code allows for demand factors to be applied to heating and cooling loads under certain conditions, particularly in the optional calculation method. Sixthly, apply demand factors as permitted by Article 220.30. The optional calculation method allows for significant demand factors to be applied to the total connected load, recognizing that not all loads will operate simultaneously. The specific demand factors vary based on the total connected load and the presence of certain appliances. For example, after calculating the total connected load, a demand factor of 40% may be applied to the portion of the load exceeding 10 kilowatts. Seventhly, calculate the service entrance or feeder size. Once the total calculated load is determined after applying all applicable demand factors, the minimum size of the service entrance conductors or feeder conductors can be calculated. This calculation involves dividing the total load in volt-amps by the system voltage to determine the required amperage. For a 120/208 volt single-phase system, the formula is amps equals volt-amps divided by volts. The calculated amperage is then used to select the appropriate conductor size from National Electrical Code Table 310.16 or other applicable tables based on the conductor's insulation type and termination temperature rating. Eighthly, consider any non-coincident loads. Non-coincident loads are loads that are unlikely to operate simultaneously, such as electric heating and air conditioning in certain climates. The National Electrical Code allows for the smaller of these loads to be excluded from the total calculated load, provided that they are truly non-coincident. Ninthly, account for future expansion. It is prudent to include a safety factor or allowance for future expansion when calculating the service entrance or feeder size. This helps to ensure that the electrical system will be adequate to handle any additional loads that may be added in the future. A common practice is to increase the calculated load by 25% to provide a buffer for future needs. Tenthly, document all calculations. Detailed documentation of all calculations, assumptions, and demand factors used is essential for code compliance and future reference. This documentation should include a load calculation worksheet that lists each load, its volt amp or wattage rating, any applicable demand factors, and the final calculated load. This documentation should be kept on file and made available to electrical inspectors or other authorities upon request. By following these steps and considerations, electrical professionals can accurately and safely calculate the load requirements for dwelling units using the optional calculation method in Article 220.30, ensuring compliance with the National Electrical Code and providing a reliable electrical system for occupants. When applying the optional calculation method from Article 220.30 to determine the electrical load for individual dwelling units like apartments, it's crucial to understand several key requirements. This method simplifies load calculation by applying demand factors to the total connected load, which helps in determining the appropriate feeder and service sizes. Firstly, the optional calculation method is primarily intended for dwelling units with a total connected load of 100 amps or greater. This means that if the initial calculation without any demand factors results in a load less than 100 amps, the standard calculation method as outlined in other parts of Article 220 should be used. Secondly, the calculation starts with determining the total connected load of the dwelling unit. This includes all lighting, receptacle outlets, small appliance circuits, fixed appliances, and heating and cooling equipment. The nameplate ratings of all appliances and equipment should be used to determine their individual loads in volt-amps or watts. For lighting and receptacle outlets, a general load of 3 volt-amps per square foot is typically used, although this is more relevant in the standard calculation method. Thirdly, small appliance and laundry circuits must be included. The National Electrical Code requires a minimum of 220 amp small appliance branch circuits for the kitchen and dining areas, and at least one 20 amp laundry circuit. Each of these circuits is calculated at 1500 volt amp. These loads are factored into the optional calculation as part of the total connected load. Fourthly, the load for all fixed appliances should be calculated. This includes appliances such as electric ranges, ovens, cooktops, dishwashers, disposals, water heaters, clothes dryers, and air conditioning units. The nameplate ratings of these appliances should be used to determine their individual loads. Special consideration is given to electric ranges, where the National Electrical Code provides specific demand factors based on the rating of the range. For example, a range rated between 8.75 kilowatts and 12 kilowatts can be calculated at 8 kilowatts. Fifthly, the heating and cooling loads must be considered. The larger of the heating or cooling load is included in the calculation. For air conditioning and heat pump equipment, the nameplate rating of the unit is used. For electric heating, the total connected load of all heating elements is used. In climates where heating and cooling loads are non-coincident, meaning they are unlikely to operate simultaneously, the smaller of the two loads can be omitted from the calculation. Sixthly, after determining the total connected load, the optional calculation method allows for the application of specific demand factors. These demand factors reduce the calculated load by recognizing that not all connected loads will operate simultaneously. The National Electrical Code provides a table of demand factors that can be applied based on the total connected load in the presence of certain appliances. For example, a demand factor of 40% may be applied to the portion of the load exceeding 10 kilowatts. Seventhly, once the demand factors have been applied, the total calculated load is determined. This value is used to calculate the minimum size of the service entrance conductors or feeder conductors. The calculation involves dividing the total load in voltamps by the system voltage to determine the required amperage. For a 120/208 volt single-phase system, the formula is amps equals voltamps divided by volts. The calculated amperage is then used to select the appropriate conductor size from National Electrical Code Table 310.16 or other applicable tables. Eighthly, the National Electrical Code also provides specific demand factors for electric clothes dryers and electric cooking appliances in dwelling units. For example, for electric clothes dryers, a demand factor of 75% can be applied. For electric cooking appliances, the demand factors vary based on the number of appliances. Ninthly, when applying the optional calculation method, it is important to consider any of the loads that may not be explicitly covered by the standard demand factors. This includes loads such as electric vehicle chargers, which may require additional capacity. These loads should be added to the total calculated load after applying all other demand factors. Tenthly, accurate documentation of all calculations is essential. This documentation should include a load calculation worksheet that lists each load, its voltamp or wattage rating, any applicable demand factors, and the final calculated load. This documentation should be kept on file and made available to electrical inspectors or other authorities upon request. By understanding and carefully applying these requirements, electrical professionals can accurately determine the electrical load for individual dwelling units using the optional calculation method, ensuring compliance with the National Electrical Code and providing a safe and reliable electrical system for occupants. Furthermore, additional considerations must be taken into account. This is to ensure the system is designed properly and safely. Firstly, the available short-circuit current at the service equipment must be determined. This information is necessary to select appropriately rated overcurrent protection devices, such as circuit breakers or fuses that can safely interrupt the available fault current. The available short-circuit current can be obtained from the local utility company or calculated based on the utility's transformer size and impedance. Secondly, voltage drop calculations should be performed to ensure that the voltage at the furthest receptacle or equipment in the dwelling unit remains within acceptable limits. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. Thirdly, the grounding and bonding system must be properly installed to ensure electrical safety. This includes grounding the service neutral conductor, bonding all metallic enclosures and equipment, and providing equipment grounding conductors in all branch circuits. The grounding and bonding system helps to protect against electric shock and minimize the risk of fire. Fourthly, surge protection should be considered to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Surge protective devices can be installed at the service entrance or at individual equipment locations. Fifthly, arc fault circuit interrupters should be installed to protect branch circuits that serve dwelling unit bedrooms, living rooms, and other areas where arc faults are likely to occur. Arc fault circuit interrupters are designed to detect and interrupt arc faults, which can cause fires. Sixthly, ground fault circuit interrupters should be installed to protect receptacles in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Ground fault circuit interrupters are designed to detect and interrupt ground faults, which can cause electric shock. Seventhly, smoke detectors should be installed in all dwelling units to provide early warning of a fire. Smoke detectors should be located in each bedroom, outside each sleeping area, and on each level of the dwelling unit. Eighthly, carbon monoxide detectors should be installed in dwelling units that have fuel-burning appliances or attached garages. Carbon monoxide is a colorless, odorless gas that can be deadly. Ninthly, all electrical work should be performed by qualified and licensed electricians who are familiar with the National Electrical Code and local electrical codes. This helps to ensure that the electrical system is installed safely and correctly. Tenthly, a final inspection should be performed by a qualified electrical inspector to verify that the electrical system complies with all applicable codes and standards. This inspection helps to identify any potential safety hazards and ensure that the electrical system is safe for occupants. By taking these additional considerations into account, electrical professionals can ensure that the electrical system for a dwelling unit is not only code compliant but also safe, reliable, and capable of meeting the needs of the occupants.